Alright, so this is the Intro to Unity workshop for Game Development Club. So this project will just be creating a simple first/third person character controller. And so we'll just import a couple of basic objects and then we'll do most of the scripting. So to start, just get Unity opened up. You want to create a new project. Name it whatever you want. And then we're going to make it with a 3D template. And then just go ahead and click Create. Just wait for it to do its thing. My computer doesn't like doing all this at once. Once you've got Unity open, just give me a thumbs up. Peter? Yeah. Yeah. That is weird. Okay, I do still get that error. I'm gonna restart it quick. Alright, so to start, we've got our scene here. We're going to add a couple objects to it so that we can add scripts to it. So we're just going to make a flat plane for the character to run around on, and we're just going to use a what's it called? A capsule as the player. Nothing too fancy, but you'll get the gist of it. So down here, or wherever it is on your screen in the scene area, you want to right click, go to 3D object and do terrain, and that'll just create a giant flat area for you, very big, just so we have something to run around on. The reason why I'm doing this is just because it comes with a collider already on it. Why is it? I hope it's not me. I don't know. It is not me.
Anyway, they shut them off. This thing right here.
Alright, so change my layout so it is the default. Hopefully that'll help. So yeah, we made our terrain. And then the next object we want to do in the scene is to create a capsule. So if you select it over here and then in the scene view you click F, it'll zoom in on it. Just so you can see it. If you look at the transform, it's really high up. We want to set that to like 5 or something, just so it's lower to the ground. Then we'll press F again. So maybe do it at 1. Yeah, put it at 1. Just so it starts on the ground, so we don't fall 1,000 feet. So yeah, that's that. So then we can actually start putting scripts on this. So just in the assets folder, just to keep things organized, I'm going to create a scripts folder. And then inside of that scripts folder, I want to go to create and then C# script, and we are going to name it camera controller. Once you've done that, you can double click on it and it should open it with Visual Studio or whatever IDE you have. If you're running into problems, let me know. So I'm just going to keep rolling through this. So there's already some functions already in here, which it kind of explains what they do. So start, it's called before the first frame update, so it's called right when the script starts, and then update is called every frame. There's 2 more that I commonly use that I'm just going to explain quick. One of them is called awake. It's basically the same as start, but it's called before start is. So when Unity first initializes everything, it'll call all the awakes and it'll call all the starts. So this is usually better for like initializing stuff, like setting up arrays and whatnot. And then the other function that is also commonly used is fixed update. And then this one, it's similar to update except for it's called on a fixed time interval. So update will happen whenever the screen refreshes. So frames per second, every frame it'll update. Whereas fixed update is used more for like physics and stuff, where it calls by default every 0.02 seconds. So there's going to be 50 physics updates, and this is basically a physics update. Which this is better for like if you're manually doing physics or like stuff like that. But the only ones that we need to use for this one are the 2 that are already here. So we'll just work with that. So the camera controller script is what we're going to use to control the camera itself, which we actually didn't set up. So we're going to go back into Unity quick. And then on the capsule, we're going to right click on it, and we're going to create just an empty game object. There's a reason for this. So this is going to be the offset, which I'm going to name offset. And we're just going to set the Y on the offset to like 0.8 or something, just so it's kind of at the top of it. And then on the offset, we're going to create another 3D object, or no, camera. We're just going to create a camera. So then that should automatically start facing forward. And if you look at the camera view, it kind of looks like a person, or first-person view. The reason why we have the offset is that if you want to switch this to third person on the camera, if you change the Z to a negative value, it'll look like it's pointing at like the top of the character, as opposed to if you didn't have the offset, it would look like it's just pointing at the middle of it, which is not really how it usually works. So yeah, that'll be nice. Third person, or yeah, if you have the Z set to 0, it would be a first person camera. Pretty much the easiest way to go about doing first versus third person. So now that we have the camera, we're going to go back into the script. Okay, so we're going to create some variables that you'll be able to see in the Unity editor. So the first thing that we need is a reference to our camera, so we can edit the values of it and such. So in order to do that, you can make it public, and then it will show up in the Unity editor. So we'll do public camera cam. So that way, if we save this and you look in Unity, it'll update. And then here's just the default in the script. We'll get to that in a second. So another thing you want with your camera controller is mouse sensitivity. So we're going to create another public float for the mouse sensitivity. Did I spell it right? Yes, I did. I'll just set that equal to 2 for now. And then now we'll need 2 private variables, which I'll explain once we start writing a little more. One is going to be called the pitch, and the other one is a float. It's going to be called the yaw. Alright, so in the update function, basically how we're going to do this so it controls the camera is when the mouse is moved, it'll take like that, and then it'll move the camera accordingly, or it'll rotate the camera accordingly using the pitch and the yaw values, which are going to keep track of that for us. So the yaw is going to be the like left and right that you look. So to set that, you want to do yaw plus equals the mouse sensitivity, and then you want to multiply that by input.getAxis, and then for an axis name we do mouse x. So what this will do is the input.getAxis, it'll get the change in mouse position, and then if we multiply it by the sensitivity, then it'll of course move faster or slower depending on what the sensitivity is. So then the other part is going to be the pitch. So yeah, so we'll do this same thing except for we're going to subtract. So it's going to be minus equals instead of plus equals. And then we'll do mouse sensitivity times input.getAxis, but instead of the x-axis, we want to be mouse y. And just make sure with the strings, they are case sensitive. So make sure you type those in right. So now we have the values. So now we can change the actual angles. So I'm going to do transform.Euler angles, and this is basically the angles in degrees, and then set it to equal to a new vector 3 with the pitch, the yaw, and then the last one is 0. So if you save that, and then you go into Unity, so now we'll add the script to the object, so it'll actually, let's see, up here. So we're going to add the script to the offset and not the actual camera itself. So if you go to add component, you can either search for camera controller, or if you find it in your assets, you can just drag this over here, and that'll add it. So to give that reference that we added earlier, if you go over here where the camera object is, you can just drag and drop it right there, and then now the script will have a reference to the camera that it can use. So now everything should be good. So if you click play, you notice you can look around. What you also notice is that the mouse is like going all over my screen, and typically that's not how games work. So I click out of play, and we're going to add one little thing that'll fix that. So in the start function, what we're going to do here is we're just going to lock the mouse or the cursor so it can't move, and then we're going to hide it so you don't see it either. Because typically if you have like a crosshair, you just put it in the middle of the screen, and that's basically where the mouse would be in a video game. So to do that, it's cursor.lockState, and then you want to set that equal to cursor lock mode .locked, and that'll lock it so the mouse does not move. It also lock it to the middle of the screen, and then you want to do cursor.visible, set that equal to false, and that is all you do for that. Got it? Sweet. So then once you're done with that, you can click save once again. Go back to Unity. If you click play, you'll notice that now the mouse is not on the screen if you look around. And then if you want to exit it, you just click escape. Unity will automatically unhide it and unlock it for you. And that is all for the camera. Okay. So, oh, also, you can delete the main camera out of here. We don't need that one anymore. Out of the sample scene. Okay, so we've done the camera, and now we're going to do the player controller. So we'll create another C# script called player controller. Very creative, I know. Which actually shouldn't be creative, really. They're supposed to be, just so you can kind of tell what it is. It's just easier for organizational methods. So this one. Yeah, actually, the camera. So this one, we're going to need another reference, but this time it's going to be to a rigid body, which we'll still have to add to the object. So we're just going to call it public rigid body so we can access it. All a rigid body is, if you don't know, is it's just like a script in Unity that's built in that lets you like put physics on an object essentially. So there'll be gravity, and it helps with collisions and stuff. Not collisions themselves, but we're mostly just using it for gravity. So when the player jumps up, they'll fall back down. It also helps with movement. So then we're also going to want some other things. So think about a player. So we'll want a public float. And we're going to want like a move speed. So public float move speed, I'm just going to set that equal to 5. I want another float, and we're going to call this one the, yeah.
Thank you. Sorry.
No, you're good. Yeah, so if you have a space in your scripts, they will not work. Sometimes Unity catches it, sometimes it doesn't. Sometimes you get to the point where you're trying to build it and it just doesn't build and you can't figure out why. And it's not fun. Alright, so yeah, we're going to sprint multiplier. Set that equal to like 1.5. And then we'll come up with one more variable that we're going to want. I want to make this one jump power. And we'll set that equal to 5. So those we'll just use those you can change them around in the editor then and play with them. But then they'll be used for movement. So for this script, we don't actually need the start method, so you can just delete that entirely. So then we're going to start with the movement. Yes. So how the movement works is, actually it'll be easier. So go back into Unity. I'm going to show you the input manager. So if you go to the edit and then project settings, you'll be greeted with this whole thing. And then on the left, there's a section titled Input Manager. Inside of there, there's a drop down called Axis. You can just open that up. It'll give you a whole list of things. So if you notice, there's one named horizontal and one named vertical. So basically Unity it's like an alias for, instead of using the keys directly in the script, you can access these axes. No, that's not a word. Directly. So if you do horizontal, then it has like a value of from -1 to 1, and it'll weight it out depending on what buttons the player are pressing. So for horizontal, for instance, when the negative button, when it's pressing either the left button or the A button, the value will be closer to -1, or if it's positive, it'll be closer to 1. And this just makes it a little easier just to manage everything. So we are going to change 1. So jump is already by default spacebar. But fire 3 is the left shift. So we can rename that, and I'm going to rename it to sprint. So that way when we click the left shift, we can just access it by using the keyword sprint. I'll show you what I mean in the code. So that is all you need to do there. Go ahead and exit out of it. And then open back up the script. So we're going to start by getting the vertical and the horizontal values from the keyboard in the update function. So you do float vertical equals input.getAxis vertical. And then do the same thing but with horizontal. Oh, that's not. So to get 2 values from the WASD or the arrow keys, depending on whichever, which you can always change those. in the project settings. So then the next thing we're going to want is the values from the camera, which I forgot to get those. So I'm going to add one more, go back up above the rigid body, one more public reference. We're in the camera again this time. So yeah, we'll need to reference the camera. The reason is because then we can get the angles from it, and then we'll use that so the player body knows which way to move. So we want to get the forward direction from the camera. So we'll make a vector3 forward, and we'll set that to cam.transform .forward times vertical with that. So basically what this does, the transform is just a thing that holds all the values for position, rotation, for every object, scale. And then the forward is just a vector3 that holds the values, like pointing wherever is forward based on that transform. So in this case it would be where the player is looking. And then by multiplying it by the vertical is like the WS, so the forwards and backwards, so that it'll move forward if the player is pressing forward, or if they're pressing backwards, it'll multiply it by -1, and then they'll go backwards. So then if we have a forward, we also need a right, or left and right in this case, so that'll just be almost the same thing, just camera transform.right, and multiply that by a horizontal. Basically the same concept, but left and right instead of forward and backwards. So then, in order to get the actual direction, we need to add the forwards and right together. So we'll do vector3 direction equals, and then you just add them together. And then that'll get the absolute direction that the player should be moving. Okay, so now if we want so now we're going to set the velocity of the player. So I want to make another vector3 called velocity, and we're going to set that equal to the direction and multiply that by the move speed. So the direction, the highest value any x, y, or z would be is 1, so that the move speed represents like the fastest they will be moving at one time. Okay, and then we'll do body, the rigid body, and then this contains the velocity, so we're going to directly actually set the velocity. And then we're going to make a new vector3, and you'll do the velocity dot x, the body velocity, the already existing dot y, and then the other velocity we already have dot z. The reason why we're doing this is because then if you're looking up, the player just doesn't start flying up, so it just uses the velocity, y velocity it already has, and we're only setting the x and the z, so it moves around. So now, if you save that script, we should have movement. We press. No, we do not. What did I do wrong? Oh, I know what I did wrong. Did not add the player script to the capsule. That might make a difference. So you can drag it over here. And then we'll have to assign all these values. So you need to add a rigid body. So if you add component, search up rigid body, and add that. And then you'll want to drag that into the rigid body position on the player script. Do the same thing with the camera. Go ahead and drag and drop that over there. And then now it should work. It does. It falls over. This looks goofy. Yeah. This is not supposed to happen. So, to get it so it doesn't roll all over the place like that, in the rigid body, there's a drop down called constraints, and then we're going to freeze the, I don't know what position it is, or rotation. I guess the Y can stay the same. So we're going to freeze the X and the Z rotations. Basically how to imagine this is, you know, like the X, Y, Z coordinates, Y is up and down or whatever. If it's like a rod going up and down, you're spinning that rod, and that's how the player is going to rotate. So the Y rotation we want to leave, because if the player turns, you want it to turn. Whereas the X and Z, that'll be it flopping over. So if you do that, now it won't flop over. Now it'll actually move around like it's supposed to. Okay. There's an outlet in the wall if you need it.
Thank you.
Yeah. Okay. So now we added the sprint option earlier, and there was no sprinting. So we're going to add that in quick. So right under the direction, we're going to make another float, and this is just going to be called multiplier. We're going to set it to 1. And then we're going to do an if statement in here. So if, and then the input dot get button, and then inside of there you do the name, which is sprint or whatever you named it to. So basically this will check if the sprint button is pressed down, or like whenever it's held down, it'll return true, so it'll run this code in the update. So then while it's sprinting, you want to set the multiplier equal to sprint multiplier. And then, so it actually shows in the velocity here, you can add on times multiplier. So now, if the player is holding down the sprint key, it'll multiply that also times the move speed, and then they will move faster. So now if you press play, move around, and you hold down shift while you're moving, you'll see yourself move slightly faster. The one thing we were missing though, is when you press spacebar, it does not do anything. So we're going to add jumping. To make this a little more organized, we're going to move all this out of the update code. It's usually good practice to not leave code in here like this. Usually just call a function. So we're going to make a private function. This is going to be called, we're going to call it try move. Just so we know that the function is trying to move the character. So if you want to just cut and paste it all into that function, it'll be the easiest way to move it. And then in the update function, you want to do try move. So all it is moving it. Should work exactly the same. So then we're also going to want to make one more void try jump. And then we'll also want to call that function in the update. So it'll try to move, and then it'll also try to jump. So in the try jump function, we want to do an if statement, and we'll get from the input again, get button down, or actually we'll just do get button, my bad, and then jump. So now when the jump button is pressed, or spacebar is the default, then it will return true, I'm going to need one variable for this. So the easiest way of going about like keeping track of if the player is on the ground or not is just when the player hits the ground, you set a variable that is true. When they jump off, you set it to false. It's like the simplest way to do it. There are better ways of doing it, but this will work for now. So up here, we want another variable, and it is just a bool, and we're going to call it is grounded. And set it equal to true. That'll keep track of if we're actually on the ground or not. So in here we need another if statement, and it's if is grounded. And then we're doing that just so that you can only jump if you're on the ground. Otherwise, if you want like double jumps, you could add code. You could have a number in here. If it's above a certain number, it can't jump. It'd be something as simple as that. But this time we'll just want one jump. So if it is grounded, we're going to set is grounded equal to false inside of here so that it knows that it's jumped. And then we'll just adjust the velocity. So we'll do body.velocity. And then plus equals. And we're going to do vector3.up. This is just shorthand, as it says in here, for writing vector, basically 1 in the y direction. And then we can multiply that by jump power. So basically this will just set the velocity, the upwards velocity to 5, and then it'll add it to the velocity so it'll jump up. And that is all that is for jumping. So now if we go into here, click spacebar, you'll jump. The problem is you can only jump once, and that is because we're not telling it that it's on the ground again. So back into the script, there's another built-in function, and this one is called onCollisionEnter. So this function is called whenever the collider on the player collides with literally anything else that also has a collider that is enabled. So we need to do one thing here. So go back into Unity, click on the terrain, and just so we can tell in the code what is ground and what is not, over on the inspector, we want to change we want to add a new tag to it. So if you click, the tag, add new, and we're going to name this one ground. Okay. And then you want to, once you've done that, go back to the terrain and change the tag to ground. It should be on that list now. And then the capsule, the player, you can just change that tag to player if you want. We don't really need to for this, but usually it's good to have everything tagged or in a layer. So yeah, now that the ground tag is there, in the code, when it collides with something, now we can check if the thing it collided with, so the collision.GameObject, and then we can do compare tag, and the tag is ground, so you just type in the word ground there. So then what this will do is if the thing it just collided with, if the tag is ground, it'll run this code. So then we just set is grounded equal to true. And now, with the player collider, or the player in here, you run around, jump, and then it'll let you jump again. And if you just hold down jump, it'll just keep jumping. And that is all that is. There is one thing though that might show, is that if you look at the camera and you start running, and then you look down, you notice that it looks upside down. It also slows down. There's a reason for that. But you can also flip the camera all the way around, which typically in a game that does not happen. It usually stops here or here. So we're going to fix that quick. So we're going to go back to the camera controller script. And then the pitch statement, we're gonna redo it. So just gonna comment it out because we don't need this one anymore. And we're gonna make another one. So this one is just gonna be pitch equals. And then we'll do mathf.clamp. So yeah, what the clamp does is it makes sure it stays between two values. So now we're going to set basically the up and down rotation so it gets stuck between up and down, basically. So it can't keep rotating forever. So we'll do the pitch minus the mouse sensitivity times input.getAxis mouse y. And then the two values, if you think about it, if looking straight ahead is 0 rotation, then looking up would be 90 and looking down would be negative 90. So the minimum is negative 90 and the up is 90 degrees. And then if you just save that, go ahead and click play again, and it should have the rotation get stuck when you try to look up and down. So there's one last thing that I will change. I didn't write in my notes, so hopefully I can figure this out. But when you look down, it's kind of annoying because then when the player looks down, they don't keep moving forward; they just stop. So we're gonna fix that. It's a little more complicated, but in the player script, we want to change the movement a little bit. Maybe I don't know. Hold on, I'm gonna look at something. Okay, so how we're gonna do this is we're gonna, in the camera controller, we're gonna add another reference up here. We call it public game object, and then we'll just call it player. Actually, it's not gonna be a game object. We're gonna make it a transform. So then we can get the transform values from the player. So make sure you save that, and then go back to Unity. And then on the offset with the camera controller script, we're going to drag the capsule into the player transform thing. So that now in the camera controller, oh sorry. Yeah, so in the offset on the player, the capsule, we have the camera controller script, so you want to drag the capsule to where the player transform is, so that we have a reference to it. Because then in the script, we're going to use it. I think we're going to use it. So now, after we've gotten the pitch and the yaw, we want to also change the rotation of the player itself. So we'll do player.Euler angles, set that equal to new vector 3, and so we don't need the up and down really. So for the pitch, we'll just do 0. The yaw, we want the yaw, and then nothing for the Z. Okay, that's all you do for the player. That'll rotate the player, which in this case, since it's just a capsule, it's round, you can't really see it. But this will help fix the movement. So that way, so back in the player controller script, in the move function, instead of the camera transform, we're just going to use the actual player transform. And then, so you can just delete the cam. It'll just say transform.forward. That's exactly what we want. Click save. So now, when you try to move, if you look down, it'll still, because the body doesn't rotate up and down, it won't affect the movement at all from the up and down on the camera. So then when you look up and down, it'll still move forward. And that is all that is. Does anybody have any questions or anything?
Oh, is that Visual Studio Code? I think it's if. I don't know, I guess you don't want to need that if they didn't want to do it. Vertical is good. Yeah, if we don't save it, then we won't make updates.
That is the end of the workshop. That's all I had planned, so.